Hello everyone, welcome to Knowledge Hub by Sri Chaitanya. This is Shravan Kumar, Senior Chemistry Faculty. This is the second session of electrochemistry. Already first session was completed, so this is the second session. In this session, we are discussing about the electrode potentials and reference electrodes. So in this session, we are discussing about these two, electrode potentials and reference electrode. Already in last session, we have discussed electrode potential is nothing but either sometimes the element is try to lose the electrons, sometimes electrons are gained. So the tendency of losing of electrons, so electrode potential, what happened here? Electrode potential means in this one what happened, either metal is or the substance is or electrode, just wait. So here either electrode is lose the electron or electrode is gain the electron. So that means the tendency of losing of electrons, or gaining of electrons by the electrode. Tendency of losing of electrons or gaining of electron by the electrode, that is known as the electrode potential. So in this one, sometimes electrode is gain the electrons. The tendency of gaining of electrons is known as the reduction potential. So reduction potential means tendency of gaining of electrons. Tendency of gaining of electrons is known as the reduction potential. Simultaneously, tendency of losing of electrons. Tendency of losing of electrons is known as the oxidation potential. But sometimes here we get the confusion. If we use the two terms, we get the confusion. So that's why to overcome this confusion, instead of reduction potential and oxidation potential, we use only reduction potential. Instead of two potential, which one we are used? Only reduction potential. Here, how you identify which is the reduction, which is the oxidation? Because of potential values they are given. So based on the potential, how you identify the which one is undergoes to the reduction, which one is undergoes to the oxidation? The simple one is here, if reduction potential values are more, undergoes reduction reaction. If reduction potential values are more, undergoes to the which reaction? Reduction reaction. Same, if reduction potential values are less, then that is undergoes to the oxidation reaction. Simple one. Whatever the values are given, in given value, the highest value is the reduction, lowest value is the oxidation. So based on that one, we get the electrode potential. Why we are choosing this? Because of to get spontaneity. What is the condition of spontaneity? Spontaneous means here spontaneity condition. So what is the definition of spontaneous? Spontaneous is nothing but if work is done without applying of any external force. If work is done without applying of any external force, that means we are not applying the any force from the externally. So there is no work is in externally. If it is happen, that is known as the spontaneous. So for spontaneity condition, delta G must be negative. If delta G, that is Gibbs free energy, is negative, then that reaction becomes spontaneous. So the relation between delta G and electrode potential of the cell is delta G is equal to minus NFE. So that means the minus is comes to the left side, we get minus delta G, that is equals to N of E. So if delta G is negative, then delta G is negative, then electrode potential of the cell became positive. At this condition only, that means if delta G negative, electrode potential is positive. For getting positive electrode potential, get positive electrode potentials, we use highest potential value is the reduction potential, undergoes to the reduction, lowest value is undergoes to the oxidation. Because of to get positive electrode potential, highest value undergoes which reaction? Reduction reaction. Lowest value is undergoes to the oxidation reaction. So, because of for getting positive electrode potential, for getting spontaneity condition, we use this. In last session, we have discussed the galvanic cell. So, what is the galvanic cell reaction? That is zinc converted to Zn plus 2, two parallel lines, Cu plus 2 is turns to Cu. This is already we have discussed in last session. So, in this one, if you write the overall reaction, here Zn is reacting with Cu plus 2, then we get Zn plus 2 plus Cu. Here what you observed, zinc is undergoes to the oxidation reaction, whereas copper is undergoes to the reduction reaction. If you see the electrode potential values, this reduction potential value is 0.34, whereas oxidation potential for this is minus 0.76. What is the reduction potential values for the copper and zinc? For copper 0.34, for zinc minus 0.76. If you see the electrode potential of the cell is equals to E reduction minus E oxidation. Already we have discussed in last session only this formula. So, two values are there. How you identify which one is undergoes to the reduction, which one is undergoes to the oxidation? That is simply already just now we have discussed. Whatever the value is highest, that is undergoes to the reduction. Whatever the value is low, then that is undergoes to the oxidation. So, out of these two, this is the lowest value. Lowest value is undergoes to which reaction? Oxidation. Highest value is 0.34 because this is the positive value. So, this is a high value. So, this highest value is undergoes to the reduction reaction. Substitute this. Then what we get? E reduction. Reduction value 0.34 minus of, what is the oxidation potential? Minus 0.76. So, 0.34 minus of minus plus 0.76. So, this is a 1.1 volts. So, what is the electrode potential of the galvanic cell? That is 1.1 volts. Okay. So, based on this one, we are identified whatever the value is highest, that is undergoes to the reduction, lowest value is undergoes to the oxidation. These always all potentials are measured in terms of reduction potentials only. Okay. So, if you see the reduction potential values, these are the reduction potential values. If you see the hydrogen atom, here hydrogen is undergoes to the, or it is with respect to of hydrogen, we are considered as which one is undergoes to the reduction, which one is undergoes to the oxidation. See here above the hydrogen, all these are, if you see all these values, then all these values are positive. So, based on these positive values, if compared to these, all these are negative. So, negative values means lowest value. Lowest value means what happened? It is undergoes to the oxidation reaction. These are undergoes to the reduction reaction. Suppose I am taking these two, 4th and 5th. 4th and 5th. If you see the 4th one, what is the electrode potential? What happened? Au plus 3 to Au. What is the electrode potential is given? 1.5. If you see the chlorine, Cl minus turns to Cl2 platinum. What is the potential is given? 1.36. See these two, both values are positive, but how you identify which is the highest value, which is the lowest value? See, 1.5 is highest, 1.36 is lowest. So highest value undergoes to the which one? Reduction. Lowest value is undergoes to the which one? Oxidation. So what happened? 1.5 minus 1.36. What's the value we get? 0.14. For getting positive electrode potential, we are do like this. That means this is undergoes to the reduction, this is undergoes to the oxidation. See the overall reaction. Here it is undergoes to the reduction, Au plus Cl2 1/2 mole, then Au plus Cl. Sorry. Cl minus half Cl2. From here to here electron is loose, so that's why here it is oxidation. From here to here reduction. So in this way we identify the highest value undergoes to the reduction, lowest value is undergoes to the oxidation. Okay. Now based on this one we will discuss the one problem. See this question. What is the question? Calculate the standard reduction electrode potential of the nickel slash Ni plus 2 Ni. Slash is given. Slash means changes. That means Ni plus 2 is changed into Ni electrode when the cell potential for the cell, another cell is given. Direct to cell is given nickel plus 2 1 molar double slash Cu plus 2 1 molar Cu. Now here what is the value we have to calculate? Electrode potential of the cell. So first of all we have to write the overall reaction. Always left side reaction is a which one? Oxidation reaction. Right side reaction is a reduction reaction. Even though here electrode potential values are given, but based on the electrode potentials, here what happened? 0.59, here 0.34. Out of these two, here this is the highest value, this is the lowest value. So based on this, highest value undergoes to which one? Reduction. Lowest value is undergoes to the which reaction? Oxidation. So the reaction is changed. So this one is changed. That means this is undergoes to the reduction, this is undergoes to the oxidation reaction based on the electrode potential values. So what happened? Electrode potential of the cell is equals to E reduction minus E oxidation. What is the reduction potential out of these two? 0.59 minus 0.34. Okay. So if you substitute this one, if you calculate it, then this value is equal to 0.25. So this is the electrode potential of the cell. In this way we are calculated. Whatever the question is given, highest value is undergoes to the reduction, lowest value is undergoes to the oxidation. Similarly, see the another question. See, before that, if you want to know about the more about the knowledge hub, please scan this. You get the total information about our knowledge center and different courses and what is the fee structure. All the details you can get here. Please scan this, then you will get the total information. Thank you. Now see this one. See the next question. What is the next question? Half cell reaction is given and overall cell reaction for the electrochemical series is given. This is the reaction. Okay. Next, calculate the standard EMF for this if standard electrode potentials are given. So standard electrode potential means if electrode potential values are measured at STP conditions. What is the STP conditions? When atmospheric pressure Okay, 1 atmospheric pressure and 298 kelvins. If you are measured, that potential value is known as the standard electrode potential. And here what is the condition? Solution must be 1 molar, 273 kelvins and 1 atmospheric pressure. Then this electrode potential is known as the standard electrode potential. Similarly, standard electrode potential of the cell is equals to E naught of cell is equals to E naught reduction minus E naught oxidation. Same to same, highest value undergoes to the reduction, lowest value is undergoes to the oxidation. So what is the lowest value, what is the highest value? Here two values are given. In this one, this is the highest value and this is the lowest value. And transfer of electrons is also same, so no change. So that means what we get here, electrode potential of cell is equals to minus 0.126 minus of minus 0.763. So minus 0.126 minus of minus plus 0.763. If you substitute these values, then you get the answer 763 0.126. So 7 we are getting, here 5 2 3, here what we get here 5. Okay, so 0.537 we are getting. So in this way we are calculate the answer. So highest value is the reduction, lowest value is the oxidation. Remember this one. Okay. Now here just now only we are discussed, that is electrode potential of the cell. This is for galvanic cell. For galvanic cell, electrode potential of the cell is measured as 1.1 volt. Now here we get the some doubts. At which condition current is produced, at which condition current is consumed? That is, if electrode potential of the cell is, just wait, if electrode potential of cell is less than 1.1 electron volt, the external potential of the cell is less than 1.1 electron volts, then current is produced from galvanic cell. At which condition current is produced? If electrode potential of the cell is less than 1.1 electron volt, then only current is produced. So what is the reaction? Zinc Cu plus 2 gives rise to Zn plus 2 plus Cu. This is the overall reaction. Okay. If current is produced, zinc is oxidized, copper is reduced. Second condition. This is the first one, this is the second one. What is the second one? If electrode potential of the cell is greater than 1.1 electron volt, less than we are discussed. If it is greater than 1.1 electron volt, then what happened? Current is consumed. If current is consumed, then the type of cell is known as the electrolytic cell, not electrochemical cell. Electrolytic cell, normal cell. So what happened? Backward reaction is takes place. Because of this is a non-spontaneous, so that's why reverse reaction. What's the reverse reaction? Cu Zn plus 2 gives rise to Zn plus Cu plus 2. Okay, this is the second condition. Now see the third condition. If electrode potential of the cell is exactly 1.1 electron volt or 1.1 volt, then what happened? Then there is no consumption of the current, then there is no production of the current. That is at equilibrium. No consumption of the current, no consumption of current, no production of the current. That is nothing but present at equilibrium. Okay. So, this is the electrode potentials of the galvanic cell. So, generally electrode potential of the galvanic cell is 1.1. If less than 1.1, produce the current. More than 1.1 electron volt, consume the current. If exactly 1.1, it is at equilibrium. That means no consumption of the current, no production of the current. Okay. So, this is the electrode potential of the cell. Now, suppose in galvanic cell or in any cell, in galvanic cell what happened? Anode is present and second one cathode is present. Sorry. Anode and second one is the cathode. So, generally what is the sign of the cathode in galvanic cell? Positive, anode negative. In presence of anode, which reaction is takes place? Oxidation reaction is takes place. At cathode, reduction reaction is takes place. Only signs are different, but remaining all reactions are same. Already in first session we have discussed about this. Okay, if you have any doubt, once refer that first session, then you will get the idea about this. Now, anode, at anode what happened? Oxidation reaction is takes place. Oxidation means losing of electrons. Reduction means gaining of electrons. Losing of electrons is known as the oxidation, gaining of electrons is known as the reduction. Suppose M is turns to M plus N electrons. Electrons are loosed, so that's why that is known as which reaction? Oxidation reaction. Next, reduction means M plus N gain the electrons, then turns to M. Here what happened? Electrons are gained. Gaining of electrons is known as the reduction. Now, this is represented as M is turns to which one? M plus N. Whereas in second one, M plus N turns to M. Both are different. Like this we are represented. Suppose single electrodes is given. Only one electrode is given. If one electrode is given, is there any chance to calculate the electrode potential of the cell? No, because to calculate the electrode potential of the cell, we require the two electrodes. One is must be acting as cathode, another one is acting as anode. But only how many electrodes are provided? Only one is given. So, at that condition, we use the reference electrode. Reference electrode means it is acting as cathode simultaneously anode based on choosing electrode. If the given electrode is acting as cathode, then reference electrode is acting as anode. If given electrode is anode, the reference electrode is acting as cathode. So, what is the statement for this reference electrode? So, reference electrode to measure the single electrode potential. If single electrode is given, we cannot measure the potential of the cell. If only one electrode is given, we cannot measure the electrode potential. We cannot measure the electrode potential directly. So, how you calculate electrode potential of the cell? By using of reference electrode, we are calculate the potential of the cell. So, reference electrodes are required. Sorry. Reference, just wait, I have to check. Okay, sorry. Okay, if reference electrode is, so reference electrodes are required. Reference electrodes are required. So what's the use of the reference electrode? Reference electrode can act as both cathode and anode. So what's the reference electrode use? Reference electrode can act as anode, simultaneously cathode. It shows the both behavior. So it can undergoes to the oxidation, simultaneously it undergoes to the reduction also. Okay, suppose if you take this one, if the given electrode is cathode, if given electrode is acts as cathode, so we require the which one? Anode. So reference electrode acts as anode, vice versa also. So based on the condition, it can act as the cathode, simultaneously it can act as anode. And for this, best example is standard hydrogen electrode. So reference electrodes example. For reference electrode, what is the example for this one? SHE, standard hydrogen electrode. SHE is nothing but which one? Standard hydrogen electrode, SHE. So that means this one is the one of the best reference electrode we have. So in this one, what happens? See, this is a electrolytic cell. In this one, 1 molar protic solution we are taken. Which one? 1 molar protic solution. Protic is nothing but acidic solution. Either maybe acid, that is HCl or H2SO4 or any acid, but concentration should be 1 molar. In this one, we use the one diaphragm. This is a way of passing of hydrogen gas at 1 bar pressure. Here it is a one platinum electrode which is coated with finely divided platinum, that is known as the platinum black also, which is connected externally. So this is a platinum electrode. Then this is a construction of the SHE, standard hydrogen electrode. So in this one, what happened? 1 molar protic solution we are taken in a electrolytic cell. In this one, we use the one platinum electrode which is covered with a diaphragm. This is a way of passing of hydrogen gas into the cell. So now see the how it is worked. Here it is already H plus ions are there. So if given electrode acts as cathode, if given electrode is acting as cathode, then SHE acts as anode. See the reaction. So anode, at anode, see this one, what happened? At anode, what happened? Oxidation reaction is takes place by losing of electrons. So in this one, H2 is converted to H plus gaining of electrons. Here in this one, it is acting as which one? SHE acts as anode. Acts as anode. Now take the given electrode. Suppose it is a M. Here what happened? It is gain the electron, then converted to M. So here electrode is acting as cathode. So overall reaction we can written as half H2 plus M plus electron get cancelled. So M plus H plus. So in this way it acts as which one? Anode. Suppose this is the case 1. See the case 2. If given electrode can act as anode, then SHE is acting as cathode. Reverse reaction takes place. So what happened here? M is turns to M plus by losing of electron. Here what happened? H plus ions are present in this aqueous solution, that is a acidic solution. That one is gain the electron, then turns to half H2. This electron get cancelled, then we get M plus H plus gives rise to M half H2. So for this, what is the representation? In this one, H2 gas, wherever you mention the gas, then you get the which one? Platinum electrode. This is the must and should condition. Is converted to H plus, M plus is turns to M. This is a representation of the for first one. See the second one. What is the representation? M is turns to M plus slash two parallel lines. Then H plus is turns to H2 platinum. Okay, this is a representation. So based on this, what happened here? SHE can act as oxidation or under acting as cathode and anode. So that's why for SHE, so here SHE can act as which one? Anode and simultaneously cathode. That means can undergoes to the oxidation simultaneously reduction. That is undergoes oxidation and simultaneously reduction. So both possibilities are there. So that's why electrode potential of the SHE is taken as 0. So that's why there is no change in electrode potential of the cell. Okay. So in this way we are using the reference electrode to measure the electrode potential of the single electrode. Okay. If single electrode is given, we cannot measure the electrode potential directly. So by using of one reference electrode, we can identify or we can calculate the electrode potential of the cell. This is the best example for the reference electrode. So many other reference electrodes also there. See this one. So another second example, metal is associated with its ion. This is the second type of reference electrode. If metal is associated with its ions, same type of ions are present, then that one is also acting as which one? Reference electrode. Suppose if you take this one, silver, if placed in silver solution, silver nitrate like that, then it is also acting as reference electrode. So what happened here? Ag is converted to Ag plus aqueous. So what happened here? Ag solid is turns to which one? Ag plus by losing of electrons. So here electrons are lost. Which reaction? Oxidation reaction. Oxidation reaction is takes place at which one? See this before this slide. Oxidation is takes place at which electrode? Anode. So that means in this condition, this one is acting as anode. So in this condition, it is acting as anode. This is the first condition. See the second. Ag plus aqueous slash Ag solid. So what happened here? Ag plus ions present in aqueous medium gain the electrons, then converted to silver in the form of solid. So what you observed here? It gain the electron. Gain the electron means it is undergoes to the which reaction? Reduction reaction. If it is undergoes to the reduction, then acting as cathode. So that means this electrode can act as both anode and cathode. That means this one is also acting as which one? Reference electrode. Okay. So see the another type of reference electrode, gas electrode, third one. Any gas is there while representation. If gas is there, along with gas you have to mention the platinum. Inert electrode you have to mention. That is a must and should condition. So in this one, gas electrode, we can simply represent it as SHA. One is the gas electrode SHA, another one electrode is platinum, Cl2 gas, Cl minus. What happened here? Cl2 gas is half mole, is gain the electron, then converted to Cl minus. What you observed here, electron is gained. Gaining of electron is nothing but reduction. So reduction means reduction reaction takes place at cathode. So at this condition, this one is acting as cathode. A. See, simultaneously this is also written as Cl minus aqueous 1 converted to Cl2 in presence of platinum. So what happened here? Cl minus is converted to half mole of Cl2 plus electron. So here what you observed, losing of electron. Losing of electron is nothing but reduction or oxidation. It is a oxidation reaction. So this is the reduction reaction, this is the oxidation. Oxidation reaction takes place at anode. Okay. So in this way, gas electrode is also acting as which one? Cathode and anode. And what is the electrode potential of the cell? Is equals to 0, because it can act as cathode and acts as anode, or undergoes to the oxidation, simultaneously undergoes to the reduction. The capacity of undergoing of oxidation or tendency of losing of electron is equal to tendency of gaining of electron. So oxidation potential and reduction potential values are equal. So that's why both are get cancelled, then we get the 0 potential of the cell. So this is the gas electrode. The another one is the fourth one, calomel electrode. So this is the most important one. So in this calomel electrode, the representation is mercury existed in the form of liquid, Hg2Cl2 slash Cl minus. This is a solid. See the reaction for this. So in this reaction, Hg2Cl2 is gain the 2 electrons, then converted to 2Hg plus 2Cl minus. What you observed in this one? Here 2 electrons are, here in this one, here 2Cl minus we get. Gaining of electrons is nothing but which one? Reduction. Reduction reaction takes place at cathode. So this one is acting as cathode. Now it is also acting as which one? Anode. Reverse reaction. What happened here? Reversible reaction. What is the reversible reaction? 2Hg plus 2Cl minus gives rise to, it is a liquid form, it is a solid form, it is a liquid. Then what happened? Hg2Cl2 solid one, then losing of 2 electrons. 2 electrons are loosed. Losing of electrons is known as which one? Oxidation. So oxidation. Oxidation reaction takes place at which one? Anode. So it can act as anode, also it acts as cathode. So in this way, this reference electrode is also acting as both cathode and anode. In this way, we get these reference electrodes. So, based on this one, if only one single electrode is given, then we cannot measure the electrode potential directly. So, at that condition, we use which one? Reference electrode. These reference electrodes are acting as both cathode and anode. If the given electrode is cathode, then the reference electrode is acting as anode. If the given electrode is anode, then the reference electrode is acting as cathode. In this way, we can calculate the electrode potential of the cell by using of the reference electrodes. See here. So, this is the session. In this session, already we have discussed the electrode potentials and reference electrodes. Now, if you face any problem, come and visit to the nearest knowledge hub center. If you want to know about the fee structure, if you want to know the courses, what are the courses we are providing, just scan this QR code, then you will get the total information. Okay. If you have any doubt, phone number is also there, then contact, then the representative will call you. Okay. Thank you.